All right, question number 15. The only part about this that I even remotely care about is that it's something for some reason that students keep mixing up. If temperature falls, that this implies only one thing. The reaction is endothermic, right? So again, it's either A or B, and if it's endothermic, delta H should be positive, 15 is B. The only reason I put that in there is because a lot of students keep making the incorrect comparison. All right, question number 16. Magnesium powder reacts with an excess of dilute hydrochloric acid to produce hydrogen gas. Which statements about this reaction are correct? So, leading to the statements. Again, read through the statements. I wish I could tell you there was another way about it. There's not. Sometimes reading through the statements will make it easy. For example, if I automatically know that one's not the answer, sometimes that helps. Now, it doesn't help much here, but in other situations it would, right? The smaller the particles of magnesium powder, the more slowly. You can stop right there. This is incorrect. It's saying that if we make the surface area of Mg go up, that's what smaller means, then the reaction will occur slower, and that's absolutely incorrect. All right, 1 second, please. All right, so larger surface area, rate goes up, not down. The higher the temperature, the faster. Now you can tick that. That one's the easiest one. Temperature is the one we tend to remember the most easily. Temperature goes up, particles have more energy, more of them have energy greater than or equal to activation, and the frequency of effective collisions goes up. All right. So as temperature goes up, rate goes up. Three, the lower the concentration of dilute hydrochloric acid, the faster the rate of reaction. All right. Again, wrong. The higher the concentration, we want more ions to be present in a smaller volume, not less ions. So the moment it said lower concentration, you immediately eliminated it. Question number 4, the faster the magnesium powder disappears, the faster the rate of reaction. That is absolutely correct. The more rapidly that we see the solid go away, the more rapidly the reaction is occurring. So the answer is C, 2 and 4. All right, question number 17. So here, 17 says that carbonates react with dilute acids. All right, carbonates, it says, with dilute acids to produce carbon dioxide. Take it. Student uses excess carbonate after 100 centimeters cubed of a zero point 0.1 molar acid and measures the volume of gas produced at regular time intervals. The results give line X on the graph. The student repeats the experiment using 50 centimeters cubed of 0.2 molar whilst keeping everything else the same. Now, here's the thing. The carbonate is excess. So what they've done is they've conducted the first experiment labeled X, right, where they used 100 centimeters cubed of zero point 0.1 molar. The second time that they do this, they lower the volume, but they increase or they double the concentration. Now, here's the thing. The number of moles remain exactly the same. Even though HCl is the limiting reactant, or sorry, the acid is the limiting reactant, they're still giving you the same number of moles. 100 over 1,000 into 0.1 is 0.01. If I look at the 50 centimeters cubed to 0.2, that would be 0.05 into 0.2, which is also 0.01. So the number of moles actually ends up being exactly the same. The only difference is that the second time around, your concentration is double the initial, meaning there's twice as many hydrogen ions in the same amount of space. So the frequency of collisions will go up as well. The answer is B. The same amount of product, even though they've altered the amount of the limiting reactant, but because they've increased the concentration, you will get the same product in half the time or in a faster period of time, so the rate goes up. B is your answer. All right, number 18, equilibria. There's three things that affect equilibrium. One is temperature, right? If the forward is exo and if you increase temperature, it goes backward because it goes endo. Simply इसतना याद रख. Temperature बढ़ता है, it always goes endo. Temperature कम होता है, it always goes exo. All right. Pressures. If you increase pressure, it goes towards lower gas volumes. If you decrease pressure, it goes towards higher gas volumes. The third one is the concentration of the materials at equilibrium, because at equilibria, everything remains constant, doesn't change. Not that the reactants of the products are equal or more than or less than, they just become constant. So if I alter the equilibrium in any way, it'll shift accordingly left or right. Now, it's asking me when the reaction has reached equilibrium, more T is added. So I put more T into the system. The moment I add more T, right, this causes the equilibrium to start to shift more to the left-hand side. Now, as the equilibrium shifts more to the left-hand side, everything on the left-hand side will automatically start to increase. The answer is C. P, Q, and R will all increase in concentration simply by adding more T into the system. All right. Number 19, rate of reaction between magnesium and dilute hydrochloric acid is investigated. The the equation is given. It says a known mass of Mg is added to an excess. Note that word, T, excess of acid. The concentration of the acid and the volume of the hydrogen produced is measured at regular time intervals. Now, here's the idea. Obviously, the volume of hydrogen will increase and become constant over time. So what we can do is we can eliminate B and C because they're not showing that. They're showing a massive increase initially and then a gradual declining. That's not what happens. It actually increases more, or actually increases this way rather than ever increasing that way. So I know that it's either got to be A or D. Now, here's the thing. The answer is D. And the reason the answer is D is because they had told you already that the acid is in excess. Matlab, the magnesium will completely run out, but the acid will not. So therefore, the actual graph plateaus out above the x-axis rather than all the way down. So you're looking at an answer of D. All right, number 20. Put a star by this one as well. Again, the reason I simply put this question is because it's a topic that IGCSEs are already dealing with, but you guys are from O levels. This is not something you've done before. So this is something that will most definitely be, if it wasn't in P2, chances are it will be in P1, but it could be in both as well. You just need to know about the way that you go about solving it. So here is your delta H, the way you're going to solve it. You will take the bond energy of your reactants, whatever those bonds may be, minus the bond energy of your product. So reactants minus products. Now, let's look at your reactants, right? 1 second, please. All right, so your reactants are 2 moles of hydrogen bonds are being broken on the left, 1 mole of oxygen double is being broken on the left, and then you're getting 4 OH bonds to form on the right. So I need to break 2 hydrogen bonds on the reactant side. I need to break 1 oxygen double bond, and I need to subtract from that the energy needed to break 4 HO or OH bonds. Now, why 4? Because there's 2 moles of water. Each water molecule requires 1 OH bond to be broken. 2 water molecules will require 4 OH bonds to be broken. All right. So you start putting the values in. That's 2 times 436 plus 495 minus 4 into 4, 63. This is your formula. This is the working. And 1 second. So we add it up. The answer should come out to be negative 485, which means that the reaction is exothermic. Now, here's the thing that they've done. They've only given you the value, not the magnitude. Oh, sorry, not the charge. So you've been given the scalar magnitude, and then by using the sign that you got in your calculation, you were to deduce whether it's exo or endo. The answer is C. All right, another question, 21. Again, not very common in O-level exams prior. Not very common IGCSE either. So this is going to be something that you're definitely going to be seeing a lot more of as we proceed and go forward. Oxidation states. Now, here's what I would do. Hint. You can go through and calculate the oxidation state of everything, but that would be very difficult with the ammonium dichromate because there's two nitrogen, which you don't know the oxidation state for as well. But there's an easier way of doing this. The entire ammonium you know to be +1. So don't change the charge. Ignore the fact that there's 4 hydrogens, 1 nitrogen. Look at the whole thing and make its charge +1 and multiply that by 2. Then you have 2 chromiums that are unknown, and then you have 7 oxygens, which are all -2 apiece, and you make that all equal out to 0. What you're going to get is -14 plus 2. You take to the other side, you will end up getting 2 chromiums equal to +12. So each chromium will maintain an oxidation state of +6. So A and B are gone. Now, the next one, you can either calculate or you can remember to do something that we did a lot earlier. Cross the valencies. Remember the formulas of ionic compounds, particularly metals and non-metals, form when you cross the valencies. So oxygen की valency 2 है जो chromium के साथ आ गई है. So if the 3 oxygen is from chromium, that means that chromium had to be 3 plus. The answer is B. Any questions? I hope this was clear enough. Using the rules of oxidation states, that's how we're solving this. All right, 22. Which of the following is, it says, a redox reaction? I mean, we hate these questions. Students really don't like them. Like, how are we supposed to just randomly look at equations and say, oh, redox, not redox? Remembering the oxidation state idea. Any chemical reaction where the oxidation states do not change are not redox. And there are 3 particular types of reactions that will never be redox. The first of which is any type of neutralization. It doesn't matter whether it's acidic solutions or acidic oxides, or whether it's alkalis or insoluble bases. Neutralization reactions will never be redox. So B is out. Any kind of precipitation reaction, like this one. Why? You're mixing 2 solutions together to form an insoluble precipitate. C will never be a redox reaction because it's a precipitation. The third type of reaction that will never be decomposition, or that will never be redox, decompositions of carbonates or bicarbonates. Because again, from left to right, oxidation states will never change. So write that, remember that. Neutralizations, never redox. Precipitations, never redox. Decompositions of metal carbonates, never redox. And if you can remember that, then the answer is a heck of a lot easier. It's